All right. Greetings and welcome. There we go. Hope everybody is doing well today. Now, I know for a lot of people this is the last day before the Christmas break, especially if you have little ones in school. So, hope everything is not going to be super crazy for you. So what we want to be looking at today is we're going to be looking at graphing, the basics of graphing. We'll be talking about how to calculate the distance and the midpoint. We'll look at graphing circles and graphing lines and writing equations of lines. At least that is the plan. So first, let me just do this. All right. So this is the graphing grid that we're going to be working with today. It's a normal graphing grid that goes from -10 to 10 in both the x and the y direction. Now, just as a reminder, horizontally that's going to be for your x, and vertically that's going to be y. When we talk about plotting ordered pairs, like if I have the point A that is 4, -3, just remember that it always goes in the order x and then y, which means point A is going to be 4 units in the x direction and 3 units in the y direction. So going to the right 4, going down 3, and this is going to be the ordered pair for that. So this is where you have the ordered pair for -3. Now, make sure that you do not confuse that with the ordered pair that is -3, +4. By having these guys in a different position, it means different coordinates, right? So it's still going x and then y, but it means in the x direction, that horizontal direction, you'd be over here at -3. And in the positive direction, you're going to be up at 4. Now, when you plot the point, it's where these guys intersect. So at this point right here, your x value is to the left 4, or excuse me, to the left 3, so -3, and your y value is +4 because it's up 4. That's how we plot points. Nothing more to that. So we don't need to get worked up about this or confused. Just go at it one step at a time. Make sure that you pay attention to your signs, and everything's going to be fine. Now, one of the things that we talk about, and again, hopefully, if you're my students, you've watched the lecture videos, so you have a good sense of what's going on. With 2 points, we oftentimes want to talk about what is the distance between 2 points. So the distance formula is, well, there's a couple of ways of writing it. If I were to write it the way the textbook, or most textbooks show, they're going to say it is the square root, and they're going to do this. They're going to say x2 minus x1 squared plus, and then y2 minus y1 squared. And really when they're using that subtraction there, they're talking about the difference. They're talking about the change in x and the change in y. Now, another way that we have of expressing this, and this kind of goes into some other algebra stuff, and you might even see this in some science classes, is that we'll use this symbol, which means delta x. So that little triangle is the Greek symbol delta, or the Greek letter delta. And in math and science classes, we use that to denote the change. So delta x is going to be finding the change between your two x coordinates. Now notice that I'm using a subscript here. It's not a power. And so this is to denote the second x coordinate versus the first one. Similarly, I can do delta y to represent the change in the y coordinates. So what I like to do, what I like to show my students, is that instead of writing this formula that you see, I rewrite it using delta x and delta y. So I'm just going to do the change in x squared plus the change in y squared. Now, a lot of times it does matter the order that you write these numbers in, because you've got the subtraction between the two x's and the two y's. But for the distance formula, it doesn't really matter. And so what we're going to focus on, or at least what I focus on, is just trying to find the difference between them. I don't care if it's positive or negative, I just want to find the difference between them, or the distance between them, because I'm going to be squaring it in the formula. And so when I square it in the formula, well, if it's negative, it's going to make it positive. If it's positive, it's still going to be positive. So we don't need to add a lot of extra issues here. So suppose I have point P is the ordered pair 4, -7, and the ordered pair Q is, let's make this 1 and -3. So I can plug it into that formula that has all of the extra subtraction and extra pieces, or I can think about finding what is the change in x and what's the change in y. So if I think about this, what is the change in x? Well, whether you go from 4 to 1 or 1 to 4, the change is going to be 3. Now, some of you might argue with me on this, but you might say, oh, it's -3. Okay, but just go with me here for a second. And what about the change in y? If I go from -7 to -3, well, since these guys are both negative, to go from -7 up to -3, you're just going up 4 units. So the change in y is going to be 4. So when I'm trying to calculate my distance, I'm just going to plug these values into what I have right here. So the change in x is 3, so that's 3 squared. The change in y is 4, so 4 squared. And then we just do the arithmetic from here. So remember, you have to do what's inside the radical first before you actually do the radical, because the radical acts as a big grouping symbol here. So 3 squared is 9, 4 squared is 16. So the distance between these 2 points is the square root of 25, which just equals the number 5. So I like doing it this way because I can easily look at these numbers, look at the x's, and see how far apart are they and how far apart are the y's. Now something you can do that might help you out is to look at a number line, and if you say, okay, how far apart are 4 and 1? All right, so here's 4, here's 1. How far apart are those? These guys are 3 units apart. If I look at the y's, I'm looking at the distance between -7 and -3, and the distance here is 4. And so that's what I'm thinking about whenever I'm coming up with the change in x and the change in y. Now, if we apply this to the formula directly, okay, so if I label this as x1, x1, y1, and x2, y2, right? The first x and y coordinates and the second ones. And now let's find the distance based on my formula. Now remember, every time you use a formula, no matter where, no matter when, always make sure that you write the formula down first before you start plugging in. This will help keep you on the right path, and it keeps you from making careless mistakes, and also helps cement the formula in your mind. All right, so big fraction here. So if I apply this formula using these coordinates, x2 is 1 minus, well, there's a 1 there, I guess it got lost, and x1 is 4. So we find that difference and we square that. So then we look at the y coordinates. y2 is -3 minus, and this is where things get kind of tricky, it's minus -7. So you got to be very careful about your signs. All right, so then we just kind of work out the rest of this. This gives me -3 squared plus, over here you have a negative times a negative, so that ends up being a plus. So we have -3 plus 7, which gives me +4. And you see here that we end up with the same thing that we had before. We have 9 plus 16. So it's the square root of 25, which equals 5. We still get the same answer. I just don't like having to plug in negative numbers when there's already subtraction as part of the formula. But if I can look at it and say, okay, what's the change in x, what's the change in y, then I'm going to be okay. All right, so let's do another example here. And let's say that P is 71, 4, and Q is the ordered pair, let's say 67, -10. All right, let's find the change in x and the change in y. So if I look at the change in x, and you might even just kind of want to do this, away from the formula, and say, let me just do 71 minus 67. So we get 4, right? And let's do the change in y. Now, I hope that you can see the difference between 4 and -10. Keep in mind they are on opposite sides of 0, right? 4 is 4 units to the right, -10 is 10 units to the left. So the total distance between them should be 14. If I do this as 4 minus, and then I do the second guy, this becomes 4 plus 10, which is 14. All right, so now I go to the formula for my distance. So we have the change in x squared plus the change in y squared. We're just going to work this out. Again, you've got a formula. You've figured out the change in x and the change in y. So we got 4 squared and we have 14 squared. If these guys had been negative, right? So if I had done this backwards and I said 67 minus 71, I would have gotten a -4. Well, that -4 would eventually have been squared, and so the negative is going to just be meaningless at that point. All right, so we have the square root of 4 squared is 16. 14 squared is 196. All right. 16 plus 196 is going to be 212. And now we have to see if we can simplify this at all. Are there factors of 212 that are a perfect square? Now, maybe you don't know this off the top of your head. Maybe I don't either. So here's what we'll do. And we've done this in previous videos. Go off to the side and take the number 212 and start breaking it down, starting with the smallest prime number, which is 2. 2 goes into 212. Think about it, let's do easy math. You're dividing by 2, so half of 200 is 100, half of 12 is 6. So half of 212 is 106. All right, I still have an even number, so let's divide this by 2. 2 goes into 100 50 times, 2 goes into 6 3 times. So 2 goes into 106 53 times. Now, 53 is a prime number. So if we were to try to do more division here, 3 is not going to go, 5 doesn't, 7 doesn't. The next prime number would be 11, but it doesn't really matter because 53 itself is prime. So the way that we're going to break this down, we see that we have a square right here because we have 2 factors of 2. So that's going to give me 4. The other factor is 53. I take the square root of both of these. The square root of 4 is 2. So my distance, fully simplified, is 2 times the square root of 53. Okay, this is an exact answer and it's simplified. So this is what we would be looking for the distance between those 2 points. Now I want to show you a slightly easier way perhaps to simplify this. I know a lot of times when we get to some of these larger numbers, It can be overwhelming. Now, we do know that we can do a factor tree, right? But let me show you something else. Let me just get rid of this real quick. I want to look at what I have. Oh, that is not the right thing. I want to look at this guy right here. So inside the square root, I have 4 squared and 14 squared. Now, before I actually square those, I want us to look at this. Is there a common factor between 4 and 14? The answer is 2, right? So here's what you can do. You can take the common factor of the squares and write that outside of the radical. And then you can divide these bases by that common factor. So this becomes 2 squared, and the 14 squared becomes 7 squared. And as we work this out, 2 squared is 4, 7 squared is 49, and when you combine these guys, you get 53. The same answer that we had the first time. But we were able to simplify this before I got to really large numbers. I think that's a pretty cool trick. Let me show it to you again, but with some different numbers. So suppose we have, let's take 5 squared plus 15 squared. The common factor for these two bases, 5 and 15, is 5. So I can factor the 5 out in front of the whole guy. But now I've got to take the 5 out of each of these bases. So it becomes 1 squared, and this other guy becomes 3 squared. And then you just take this and you work it out. So 1 squared is 1, 3 squared is 9, and we end up with 5 times the square root of 10. That's it. Now, you might say, are you sure? Maybe you're tricking us, right? Well, I'm not. If we do this the long way would say square each of these numbers, all right? So 5 squared is 25. 15 squared is 225. These numbers combine to give me 250 inside the radical, and 250 can be broken down as 25 times 10. The square root of 25 is 5, so we're left with a 5 on the outside of the radical and 10 on the inside. So it still works out. It just kind of saves us from getting to really large numbers and then having to break down those larger numbers. I'm all about shortcuts as long as they are legitimate shortcuts. All right, so that's calculating the distance. Now, the next one is a formula for the midpoint. So the midpoint is going to be the point that is exactly halfway between 2 points. It's going to be equidistant from either of those points. The formula for the midpoint goes like this. You add up those x-coordinates and you divide by 2. And then you add the y-coordinates and you divide by 2. That's it. In other words, you take the average of the x and the average of the y coordinates, and that forms your ordered pair. There's nothing else for you to do with that. Now, I do want to point this out to you. That's addition. So you don't need to worry about changing any signs. You just add the x coordinates and you add the y coordinates. Compare that over here to what we had for the distance. For the distance, we have to find the difference because we're trying to find the change in the x and the change in the y. But the midpoint is not about the change. It's about adding everything together and dividing by 2. You're finding the average. So if I say that P is the ordered pair -7, 21, And Q is the ordered pair 13, 47. All right, so my midpoint, and we'll use a capital M for the midpoint, is going to be doing the average of the x and the average of the y's. So if we plug that in, we will have -7 plus 13 divided by 2 for the x coordinate, and then for the y coordinate, it's going to be the sum of those y coordinates divided by 2. And what you get here is just a matter of, do the simple math that we have. So -7 plus 13 is +6. That's divided by 2. 21 plus 47 is 68, and then we'll divide that by 2. And so we end up with our midpoint. Now keep in mind the midpoint is an ordered pair. It's a point, it's a location on the xy plane, so it has to be given as an ordered pair x comma y. So we have 3 comma 34. And if you were to look at this, I know it's kind of hard to imagine, but 3 is halfway between -7 and 13. Maybe it's not that hard to figure out. Look at it this way. If I do a t-table of values here, where I have P, have Q at the end, and I put my midpoint in the middle. I just want you to see what happens here. The coordinates for P are -7, 21. The coordinates for Q were 13, 47. And my midpoint, I'm claiming, is 3, 34. Now, if this really is the midpoint, that means that as I go from P to Q, as I get to the midpoint, I've gone half of my distance. So look at this. As I go from -7 to 3, I have increased by 10. If I go from 3 to 13, that is another increase of 10. So I hope that you can see that 3 is exactly halfway in between. Just like if you're going on a road trip and you've gone, 200 miles, but you've only gone halfway, you're at the midpoint, right? That means you need to go another 200 miles. Well, thank you. Appreciate that. T.H. Eriks. Tharix. It's always weird how to say people's usernames. I try to make it nice and easy for mine. It's Mathman, right? Because I'm a nerd. Now, if you look on the Y part, you're going to see the same thing happen. From 21 to 34 is an increase of 13. And you should be able to figure this out. Like if you're 21 now, in how many years will you be 34? Well, that's an extra 13 years, right? If I go from 34 to 47, that's also an increase of 13. So you can see how the midpoint is exactly halfway in between those guys. Keeping that in mind, I'm going to change this problem up just a little bit. So if I tell you that we have one point, and let's call this 7, -22, and suppose I give you the midpoint, so it's a little bit different now. If I give you the midpoint as being, let's say, -15 and let's say 40, because I don't know. I just, lack of creativity, I guess. And I want to know what are the coordinates for the other endpoint. So I guess there's kind of like, you can use the midpoint formula for getting that. I want to show you what I think personally is the easiest way to work this out. And that's by creating a t-table just like I did above. Now for this t-table, we've got to make sure that we put our endpoints at the end and we put our midpoint in the middle. I know it seems obvious, but yes. Oh, well, thanks for stopping by, Tharix. So the midpoint has to always go in the middle. So -15 and 40 goes in the middle. One of my endpoints is going to be 7, negative 22, and I want to find out what are the coordinates for my other endpoint. Well, just like we had above, let's see how far we had to go just to get to the halfway mark. So to go from 7 to negative 15, you're at positive 7, and then you end up at negative 15. So think about how far away that is. And if you struggle with that, draw a number line just to get a sense of where you are. So here's 0. You're at 7, and you want to go all the way back over here to negative 20. Oop, my eyes are wandering. All the way back over here to negative 15. Well, how do we do that? Well, you have to first go 7 units back to get to 0, and you have to go another 15 units to the left to get to negative 15. So that total change as I go backwards 7 and then backwards 15 is going to be a change of minus 22, which means it's negative 22 change for my x coordinate to get to the midpoint. So to get to the other endpoint, I'm going to subtract 22 again. So we've got negative 15 minus 22. These guys are both negative. So we have negative 37 for the x coordinate. Now let's look at the y. So I'm trying to go from negative 22 to positive 40. So here's 0. Here's negative 22, and here is positive 40. How do I go from negative 22 to positive 40? Well, I have to increase by 22, and then I have to increase that by another 40. So you have to add 22, add 40, so that's a total change of plus 62. And then we have to do it again. So that's only getting us to the halfway mark, so we add 62 again. 40 plus 62 is 102. Now, to make sure that we completely answer the question, you want to make sure you do it in the correct format. So that means that point Q is going to be the ordered pair negative 37, 102. And you can see how we're making that change for both the x and for the y. Now, we should be able to go back and check to verify that this is going to work out to give us the correct midpoint. So let's just do a quick check over here on the side. So if I take 7 and negative 37 and divide that by 2, that's taking the x coordinates for your endpoints. Do the same thing for the y's. You have negative 22 plus 102, and I divide that by 2. Let's see if when I do this calculation, I still get the midpoint. All right, so this is negative 30 divided by 2. Negative 22 plus 102 is 80 divided by 2. And this gives me negative 15, positive 40. So it checks out. So it's all cool. So there's a longer way of doing this. I just don't really want to, I don't want to get into that right now. Shoot, you know what? Let's just do it. Why not? Okay, so the longer way is to actually use that midpoint formula. So the midpoint formula, as we've said before, is x1 plus x2 over 2 and y1 plus y2 over 2. So in this example, we know our midpoint. And so our midpoint was given to us as being negative 15, positive 40. And we knew our x1 and we knew our y1, because these guys were given to us as, what was that? 7 and negative 22. So 7 and negative 22. So we can write this as 7 plus x sub 2 divided by 2 equals negative 22 plus y sub 2 over 2. Now, the only way that these ordered pairs can be equal is if the x coordinates are the same and the y coordinates are the same. All right, I'm going to pause here for just a second. All right, so we can set these equal to each other. So if I take negative 15, that's going to be equal to 7 plus x2 divided by 2. And I'm going to take 40, and that's supposed to equal negative 22 plus y2 divided by 2. So we create two smaller linear equations to solve. Now, the first thing you want to do is to multiply both sides times 2. That way we get rid of those pesky fractions. So negative 30 equals 7 plus x2. Subtract 7, and wouldn't you know it, we end up with negative 37, which is what we had the first time. Now, we do the same thing over here, so multiply this times 2, multiply 40 times 2, we have 80 equals negative 22 plus y2, because these factors reduce away. Add 22 to both sides, so plus 22, and we have that 102 equals y2. And so that tells me that the ordered pair should be negative 37, 102. And if you scroll back up here, you'll see that's what we had the first time. Now, what I like about doing this t-table is that to me it's very intuitive. You see that, okay, I have to decrease 22 units to get to the halfway mark, which means I have to decrease another 22 to get to the end. For the y, I have to add 62 to get halfway, add 62 to get to the other end. So yes, Larix, I am a teacher. I'm a professor at a local community college. Been there for almost 24 years. 23 years. Yeah. And you said it's past your bedtime. I'm assuming that you are in a different country. So if you don't mind me asking, where are you from? Maybe you're looking for math videos to help lull you to sleep. I don't know. All right. So that's finding the midpoint. Now, what I think is the really fun stuff is when we start talking about circles. There's not a whole lot to do with circles as long as you know the form that you're working with. So in the textbook, it's kind of weird where they introduce circles at the beginning of chapter 2, and then they don't really go into much more after that in terms of conic sections. Now, if you were doing something like pre-cal, you get really in-depth with parabolas, ellipses, and hyperbolas. But in college algebra, we don't really see it too much. So the formula for a circle is going to be this. X minus h quantity squared plus y minus k quantity squared equals r squared. And the information that we gather from here is that our center is given by the ordered pair hk, and our radius, this is where students make careless mistakes, our radius is just r. So on the right side of the equation, we're going to see r squared. But we don't take that number as it is. We would have to take the square root in order to identify the radius that's just r. Another thing to point out here is that in this form, and we're going to see this with some videos that we do next week, you have subtraction. But I'm trying to identify what comes after the subtraction. So whenever I do that, I'm going to have to do the opposite of what I see. So let me, hold on. There we go. So if, for example, I do x plus 2 quantity squared plus y minus 4 quantity squared equals, let's just say 16. As I match it up with the form that I see above, my center is going to come from those numbers that I see in those factors, with the x plus 2 and the y minus 4. But I do the opposite of what I see. So even though with the x I see a plus 2, My center is going to have the coordinate -2 for the x. And next to y, I say y minus 4. So I'm going to do a +4 for that y coordinate. Now, this guy over here, this means that r squared is 16. So r is going to be the square root of that, which is just 4. So we say our radius is equal to 4. All right. So now that we have that information, I'm going to show you how we can easily plot this graph. So hopefully this works out well. There we go. All right, so when you are graphing, plot the center first. Now you got to be careful though. The center is not a solution for the circle. The center is just a reference point. So we're going to go to -2, +4. So -2, +4 is right here. Now I'm going to do an open circle, because if I were to do a full-on circle, full-on point, then it's as though I'm saying that is part of the solution set, but it's not. It's a reference point. And then we're going to start with the radius to help us get some nice points that kind of create the shape for the circle. So using the radius, from the center, you want to go up, down, left, and right 4 units. So up 4 units, down 4 units, to the left, and to the right. So these guys should all be equally spaced around the center. In fact, that's what it means to be a circle. It's the collection of points that are equally distant from one central point called the center. And the distance that they are all away from the center is called the radius. Now here's the tricky part. We got to draw a circle, and we only have 4 points. Do not draw a diamond. A diamond is not a circle. So this is one of those things that if you just kind of sketch it out, and you don't try to do like one motion of your pen or pencil, it goes a lot better. And that's one of the first techniques that I learned when I took art classes way back when, and that is to sketch. So kind of doing what I'm doing here. So if you do like little marks as you go around, then you're less likely to be completely off by the time you get to your destination, right? Because you can make little adjustments as you do that. So is this a perfect circle? No. Is it pretty good? Yeah, I think it's pretty good. Now, I mean, I don't want to brag or anything, but yeah, I could put that on a bicycle and probably not feel a thing. All right, so that's graphing a circle, right? Hopefully no big deal. I hope. Let's do, well, let me do this. If I were to write just x squared plus y squared equals 25. If I don't have a very obvious plus or minus inside with the x or the y, well, what is there? And if you're thinking, well, it's just a 0, you're right. So in this setup, my center is the ordered pair 0, 0, which happens to be the origin. And my radius would be the square root of 25, which is simply 5. So, tell you what, I'm just going to draw it on the same graph. So I'm going to do this guy all in blue so you can see the difference here. So my center is here at the origin. I'm going 5 units up, down, left, and right. And I just have to connect the dots. So how bad can that possibly be? All right, so it just takes a bit of practice. And I do not claim to be perfect by any stretch of the imagination. But I'm doing my best to make something that looks like a circle and not a diamond. Ta-da! There we go. Now, sometimes there's a little bit more work to be done when it comes to these. You know what? I bet I'm going to regret. All right. So sometimes things are not written in that nice center radius form. And sometimes we have a problem that looks like this. It's x squared plus y squared minus 8x, let's say plus 18y. Let me do some quick math up here. Let's say minus 3 equals 0. So what we have to do here is that we have to put this in center radius form. So this form is called just the general form for a circle. But if we put it in center radius form, then we can easily identify the center, and we can find the radius, and then graphing from there shouldn't be a problem if it were to ask us to do that. But here's what we have to do. In order to get in that center radius form that has these factors that are being squared, we're going to have to complete the square. But to do that, we need to do some rearranging. First, just like we've done with completing the square, we talked about this a few days ago, move your constant to the other side. And while you're doing that, I want you to rearrange these variable terms so they kind of go together. Meaning, I'm going to put x squared and minus 8x together, and I want you to leave a gap, and then we bring down the plus y squared plus 18y, and leave a gap there, and then we have the positive 3 on the other side. So we're setting this up so that we can complete the square. So all the stuff here on the left, I'm hoping will become x with something squared, and then plus, we'll have y and something squared over in the second half of that. Now on the right side, we're not going to have 3 because whatever adjustments I make to complete the square, I have to make those same adjustments to the other side. All right, so let's complete the square. Half of negative 8 is negative 4, and negative 4 squared is a positive 16. So we'll have to have a plus 16 to complete the square, but I have to add 16 to the right side so that I maintain balance, right? Nothing new there. For the y's, what goes in the factorization is going to be half of 18, so that's going to be plus 9, and 9 squared is 81. So I needed the 81 to complete the square, but to maintain balance, I have to add 81 to the other side. All right, so the left side looks really good. The right side, I just got to combine these guys. So 3 plus 16 plus 81 is 100. All right, so this is my form. And from here, I can identify my center. Again, doing the opposite of what I see here. So the opposite of negative 4 is positive 4. The opposite of positive 9 is negative 9. Excuse me. The radius is supposed to be the square root of 100, but you don't leave that as the square root of 100. You actually simplify that. And so we end up with 10. So asking, do they teach this in college? Like, are you fra? Well, this is in Chapter 2 of College Algebra, so yes, we do. This is one of those topics that we cover in that course. And that's going to be the same in pretty much any college algebra course that you would take. Now, you might be saying, oh, I did this in high school. Great. You know what? I did this in high school too. There's a lot of stuff in high school. Now, not everybody does that, and everybody has the same, math experience or background. Like for me, I never took college algebra in college. I never took trigonometry in college. I never took pre-cal. I never took calculus 1 in college. Started in calculus 2. But that's because I had really, really good math teachers. Well, really like the same guy for 3 years for algebra 2, pre-cal, and calculus. And I was so prepared when I got to college that even calculus 2 was a breeze for me because it was the exact same stuff that we had just done. So I'm always been very, very thankful for the instructor that I had. He was amazing. Now, another thing to think about is that a lot of the students that I teach are non-traditional students. So some of them have been out of school for a very long time. They've raised families. They have started careers. Now they're changing careers. Some of them are, in the 30s, 40s, 50s. So yeah, for some of them, this might be new to them. See, I like this stuff. Makes me happy. One of the things I want you guys to do, if you are following along at home, if you're doing this, try to be as neat as possible whenever you are writing. I take certain pride in making sure that my stuff looks fairly neat. I want to make sure that everything is legible. Now let's try another one. If I do x squared plus y squared, let's say plus 20x plus 14y, excuse me, let's say minus, got to make sure I do the math right, minus 51 equals 0. Let's see if we can take this equation, just like I did the one above, and convert it into the center radius form. All right? So just like above, we're going to move the 51 to the other side, and we're going to rearrange our variable terms. So we'll have x squared plus 20x, leave some space, and then we have plus y squared plus 14y, and again, leave some space, and on the right side of the equation, we have a positive 51. All right, start there. Yeah, so around here, where I live, a lot of this stuff will be taught in, say, Algebra 2 in the high schools, which students will be taking, usually take as a sophomore, I think, but it all just depends. Some of them start math, they start algebra a little bit earlier than others. Some of them may just be taking Algebra 2 as a senior. It all depends. Everybody takes different paths through high school. So you just never know. You know what? I think I feel very fortunate that even though I grew up in a very, very small town, I had amazing teachers for math and science, which is probably why I'm kind of oriented academically that way. I didn't necessarily have really strong English instructors. And so I never really liked that. Now, I can do that stuff, and I can do it a whole lot better now than whenever I was younger, but that's come from maturity and from working at it and knowing that my first draft is not my final draft. I had an issue with that. It was an ego problem where a rough draft, what do you mean it's not good enough? Now I know, oh yeah, there's definitely room for improvement, and I can understand that without getting down on myself. All right, so here I've got to fill in the factorization. So half of 20 is 100. And then I've got to square that guy, so I'm going to put plus 100 here. And I also have to do that on the other side, right? Don't forget that, because you have to maintain balance. For the y's, half of 14 is going to be 7, and 7 squared is 49, which again, I have to balance here on the right side with the plus 49. So 51, oh, appreciate that. if I can read what that says. Yeah, I have no... Cala, I don't know. That's a whole lot of letters there. Boy, I wonder if I can make can I make this look larger? I don't think I can. Why can't this be larger? There's got to be a way. What if I know I'm gonna mess this up if I do that. Oh! Ah! Sorry that I'm doing this live on stream. I just figured out how I could take my little chat box and make it the font larger. All it took was me holding down Control and using the scroll wheel on the mouse. It's amazing what you can learn every day. Yama. Okay. Cool beans. That is so much easier. Not to say that I wouldn't try to actually say your name if I knew what it was. Like, again, where I teach, I have students from all over the world, and I do my best to say their name correctly. I will never intentionally say it the wrong way, because I always see that as a sign of disrespect. But again, if you're from another country, and just understand that I'm very much I don't know, I have a hard time saying, certain words or saying it the right way. If your native language is something totally different, I will try. But I don't want to offend. And so if you say, you know what, just call me Johnny. Good. Nice to meet you, Johnny. All right, so now that we have it in this form, the center is, remember we got to change the signs of what you see here. So this is going to be -10, -7, and your radius. The radius is going to be the square root of 200. Now, unfortunately, that's not a perfect square. But you know what? I'm not crying, because I remember when we were doing these on the first video this week, talking about simplifying radicals. 200 can be broken down as 100 times 2. Again, each of these has its own square root. The square root of 100 is 10. And so we end up with 10 times the square root of 2 as the radius for this. Now, understand, this is not anything that I want to graph. Now, the one that we had above, the radius was just 10, I think. Yeah. This one, I could graph. I could plot 4, -9, and I could do 10 up, down, left, and right. Not a problem. Don't really want to do that with a radius of 10 square roots of 2. So for a problem like this, and especially if any of my own students are listening to this either now or in the future, you see questions like this on the test where I'm just saying, write your answer in this center radius form, and then I say identify the center and identify the radius. And what a lot of students forget when they do the center radius form is they forget that there's supposed to be a plus right there. If you don't have the plus, it's as though those parentheses are right next to each other, and when parentheses are kissing, they're multiplying. And that's not what they're doing here. Now, actually, in your syllabus, just bored. Well, I'm so glad that I can be part of your anti-boredom. Now, to show you what kind of boredom I go through and how I try to stave that off, even though I'm not teaching it, I do have this guy. I have a calculus book. Now, I took calculus many, many years ago, and I actually have, well, somewhere in here, I still have my calculus textbook from when I was in college. That was a long time ago. If you can't tell it was a long time ago, just look at the white. But this past weekend, also went to a used bookstore and I picked up a statistics textbook and a textbook for finite math and business calculus. So, not really strong in statistics. Only took a couple of classes and it's been a really, really long time. But the finite math and the business calculus, at least the business calculus stuff I'm good with. I just want to go through it and practice it more just in case I'm called upon to teach that at my school. Just like now I'm teaching trig and pre-cal, even though that's not what I was hired to do. The stuff I was hired to do, they don't really offer those classes anymore. And I don't want to do all just college algebra. That's way too much. So anyway, take up science as a main subject in 11th just for fun. Yeah, you know what? It's good to take some... You can take classes for fun, and it can still be educational. Like one of my 4 fun classes that I took when I was in college was Greek, because I didn't even need Greek, but my last semester in college, I needed to have 12 credit hours to maintain my full-time status. I only needed 10 to graduate. But if I'd only taken 10 classes, my tuition would have been something like, I don't know, let's say $3,000. But by taking that extra class, my scholarships kicked in because it was full-time, and then my tuition was $50. So yeah, I took Greek for fun. Had a friend who already had a textbook, so I didn't have to pay for that. And my tuition was decreased by like $3,000. So that's how you do it. Just got out of calculus too. Ah, fun. What is that? It is not Stewart calculus textbook. I'm trying to remember who the authors were for the one that I had in college. Differential equation. I want to go back and learn that and practice that a little bit more. It's just been so long. I don't think that my textbook from college is the greatest. I don't think my notes were the greatest either. Where you live, sciences, maths, chemistry, physics, and English too. We have to take English here. So you say like where you live. So where do you happen to live? We can't take up classes. It's like assigned. We take subjects. Yeah, I know there's certain classes like you have to have. You can't avoid it. Like everybody here has to take. You got to take your 4 years of English, a couple of years of a foreign language, your math and your science and social studies. Like it's all those little things that you have to do. But then you have room to take extra classes if you want to. So, some students will want to take, beyond biology and chemistry, they might go on to take physics, or maybe they're taking life science instead, and really around here, it's amazing the kinds of classes that they offer. Stuff that I didn't have where I grew up. I mean, they're taking engineering classes, all kinds of things with computers. Again, when I was in school, I guess they had computers, but not like they have today. It's fixed. Yeah, and around here, like some people are doing almost like, I don't want to call it a major in high school, but they're definitely picking an academic focus. And so they're taking classes that are really for that in addition to the classes they have to take. But again, where I'm from, I wonder if they have that there now. It's been a long time. But you don't have, like where I grew up, there were only 2 public high schools in the entire county. And the other high school would bus students to my high school in the second half of the day so they could take classes like pre-cal and physics and chemistry too. But let's move on. So let's look at graphing linear equations. Now, for a lot of people, you probably remember how to do this stuff. But we want to make sure we understand how to graph correctly, because later on we're going to be looking at things that are non-linear. So the graphs are not made up of straight lines. And really when we get into that next week, you really want to make sure that you pay attention to that, because I want to try to make graphing as easy and simple as possible. And I've seen students that have come to me after seeing a tutor or watching some video online, and then I see the work they do, like, I showed you the easy way. Why are you doing it the hard way? But I digress. So with linear equations, there are 2 forms that we see. One form is called the standard form, and that's ax plus by equals c. So this is our standard form. So anything that is a line can be written in this form. Whether it's a horizontal, vertical, or slanted line, it can be written in standard form. And then we have this guy, y equals mx plus b, which is our slope-intercept form. Now, we call it the slope-intercept form because from this form, we get two very key pieces of information for graphing. We get this guy right here. So the m, we call it m. Sometimes you might see this written as y equals ax plus b, like little ax plus b. This m is our slope. And if you remember about slope, slope is the ratio of how you rise to how you run. In other words, it is the change in your y direction over the change in your horizontal direction. It's a ratio of these two changes. You might also see this using the symbols that we talked about earlier today as delta y over delta x. The thing to keep in mind, though, is that slope is a ratio. And as a ratio, we see this all the time in the real world. Your slope could be something like this. Like it's, you could talk about how much you get paid per hour. And so you might say, oh, I get paid $15 per hour. It's a ratio. It's, in this case, it's a rate, $15 per hour. It might be that you are getting 42 miles per gallon, right? Or maybe you're looking at the cost of tuition, and you find out, oh, the cost of tuition is $250 per credit hour. And you could use that and come up with an equation that describes what your tuition cost is. It might be that your tuition cost is 250x plus 45, where that 250 is your slope. X is going to represent the number of credit hours that you're taking. So each additional credit hour is going to be another $250. Now that plus 45, though, is something that's not being affected by the slope. It's just always plus 45. No matter how many credit hours you take over there, it's always going to be plus 45. And kind of connecting to what I mentioned earlier about business calculus, we could see this as being a fixed expense or fixed cost versus a variable expense. So one that changes based on, how many items you're working with. But this 45 here, and let me climb back up here just a little bit. This b gives us our y-intercept as the ordered pair 0, b. Right? So don't ever say the y-intercept is b. The y-intercept is the point on your graph where you cross the y-axis. And if it's a point on a graph, especially the xy plane, points must be given as an ordered pair x and then y. So in this example that I have down here, my slope is 250 and my y-intercept is the ordered pair 0, 45. Yeah, actually, I'm just looking at the comment here. Study is not meant to be fun and more like endless competition. I can see that, and I know like around here it definitely is that way, as everybody's jostling for position and class rank so they can get into universities that only take so many students, or you have to be in the top 10% or top 5% to even be considered before you can even apply. Yeah. And I think there was some of that going on when I was in high school, but it's really just me competing with like one or two other people for class rank. Other than that, I mean, there were like clubs and stuff that I participated in where we competed, but Nothing really major. All right. So some other stuff that I want to talk about here with linear equations is just some common things that you're going to see. When we talk about an x-intercept, this is going to be the point where you cross the x-axis. And these will be of the form a, comma, 0. The y-intercept, the place where you cross the y-axis, is 0, comma, b. So these are the things that you need to keep in mind about these x and y intercepts. Part of the coordinates you already know. So if you think about your xy plane, so here's x and here's y. If I just have a random line like this, the x-intercept is going to be right here. This is your x-intercept. And what we know is that we're on the x-axis. And in order to be on the x-axis, you're not above it, you're not below it. So that means your y value has to be 0. And then, of course, you'd figure out what your x value is. If you look down here at your y-intercept, the y-intercept is where you are crossing the y-axis. You're not to the left of it where you're negative for the x. You're not to the right where you have a positive x. You are on it, so that means that x is 0. And you just figure out what the y value is. Some other things for us to know. When we talk about our slope, now we've already talked about this a little bit. The slope, we usually represent little m for the slope. The 3-word phrase that pays for slope is rise over run. To calculate this and to write our slope formula, go back to how we talked about rise over run above. We said this is the change in y over the change in x, delta y over delta x. And we talked about those changes on the first couple of pages here when we did the formula for the distance. So the change in y is the change in the y coordinates, so that needs subtraction, over the change in the x coordinates, so x2 minus x1. This is your formula for slope, which is going to be useful in a little bit. All right, the one last thing that I want to talk about in terms of these formulas is one that I rarely use, and that's the point-slope formula. Now, I say that I rarely use this. It's because I rarely use it now. Back in the day, I used this all the time because it was all I knew. The point-slope formula is going to do this. It's going to take a point, and we'll call that x1, y1, and it's going to take the slope, m, and it ties all of these guys together. And so this becomes y minus y1 equals m times x minus x1. That's your point-slope formula. And so we're going to be using that, or, well, you can use this to write equations for lines. And all you need is a point and the slope. You throw it into the formula, and you manipulate it to whatever you need. If you need it to be in slope-intercept form or standard form, you can do that. But I'm going to show you, hopefully, what is a much easier way to tackle problems whenever we need to find equations of lines. All right, so let me come over here, and let me just do this. If I say 3x plus 2y equals 8. And I want to talk about finding the slope and the y-intercept. Because if you have the slope and you have the y-intercept, you can easily get the graph. So let's do that. Let's see, if I look at this, it's not in slope-intercept form. So to be in slope-intercept form, I have to solve for y. So that means if you're not y, you go to the other side of the equation. So I'm going to subtract 3x on both sides. Now, if you've done this enough times, you probably don't need to write that, and you can just move it over and write that as a negative 3x. So we got 2y equals negative 3x plus 8. And before you even ask, what if I write 8 minus 3x? It's the same thing. However, think about the formula for the slope-intercept form. It goes y equals mx plus b. So if we put the variable term first and the constant term at the end, then we're putting it in the same format for the slope-intercept form. Now the last thing to do here is to get y by itself. So divide everything by 2. Now I can just do one big fraction bar on the right side, but it'll be easier if I just divide each of these guys by 2. It's the same thing as dividing the whole side by 2. Each of these pieces gets divided by 2. So we end up with y equals negative 3/2 x plus 4. Now before we go on, I want to make sure that we are very clear about something. When you have a coefficient that's a fraction, you need to write the fraction bar horizontally like this. Don't write that. When you write it like this, it looks like x is connected to the 2, which is in the denominator. X isn't supposed to be in the denominator. It was in the numerator, right? So you can't write that. And you might say, okay, well, what if I write this? Negative 3 over 2, and I put the x next to it like that. That's still a bit confusing. It still looks like you have x connected to the 2 that's in the denominator. So the way that we're going to avoid confusion, and the way that we avoid that ambiguity, is we write it like the way I've written it, where that fraction bar would almost go right through the middle of the variable term. All right, so do it the right way, not the wrong way. Now from here, let's identify our key pieces of information. Match this up with the slope-intercept form. So we can see that my slope is just the coefficient of x, and that's going to be negative 3/2. There's no x here, right? The slope is not x. It's the coefficient of x when you have solved for y. And then we have the y-intercept, which is going to come from that b value, but it's not the b value itself. It's going to be the ordered pair 0, 4. So taking all of this, we are now going to graph, and we're going to graph accurately. So you got two pieces of information. You've got your slope and you've got your y-intercept. The slope is it's a movement. Okay, it tells you how to move, but you need to know where you're starting, and that's where the y-intercept comes in. The y-intercept is your starting point. So we're going to plot that. I know this sounds ridiculous, but every y-intercept gets plotted on the y-axis. Right? Don't put the y-intercept anywhere else. So 0, positive 4 is going to be right here. And now we use the slope. And remember that the slope is rise over run. Also keep in mind the fact that we have something that is negative. A negative slope means that as I go from left to right, I'm going to be going down. So as I make my change here, my rise over run, I'm going to go down 1, 2, 3, and then go to the right 2, and I'm going to put another point. So we keep doing that. We go down 3 units, over 2, and we put a point. And we keep on doing that until we get to the edge of the graphing window. Always graph to the edge of the graphing window where possible. But let's look at what happens on the left side. So let's reverse this. Instead of going down and to the right, let's go up 3 and to the left 2. Do that again. Up 3 to the left 2. And what you'll see, hold on. I know, sorry, I'm looking for a ruler to make things look nice and neat. But of course, I'll use this. I think this is a Christmas stencil. Sure, why not? Now, I guess I don't have to use a ruler, but while I'm here, I might as well. Let's make it look nice and neat. All right, so this is our graph. And I want to make sure we understand the reason why we do the graph. Graphing is not just something we do because we're bored, we have nothing else better to do. But the graph, okay, so this line, or this graph, this line represents all solutions to our equation. That means that any point that you see on this line is supposed to make that original equation true. Even if we go all the way down here and grab this guy. So this is the ordered pair 6 and negative 5. If I were to replace x and y with 6 and negative 5 respectively, I should get positive 8. So let's check that real quick. So 3 times 6 plus 2 times negative 5. This gives me 18 minus 10, which equals 8, which is exactly what we were supposed to have. Okay, so that's why we graph. The graph is a visual representation of excuse me, all the solutions for this equation. Now, something else I want to point out when it comes to the slope. If I were to pick any 2 points on this graph, and I try to calculate the slope, it's going to reduce to give me negative 3/2. For example, if I go from here down to here, if I look at the change in y to the change in x, this ratio, my slope, is going to be the same throughout the entire graph. So my slope, which is rise over run, as I go down, I'm going down 6 units. And as I run, I go to the right, that's going to be 4 units. So negative 6 divided by 4 is going to give me negative 3/2 whenever I reduce that. Common factor of 2, so we get our slope right there. I could have picked any other pair of points, and it's still going to reduce to give me negative 3/2. And so that's what graphing would look like. Now, some other kinds of things to consider. I know this is kind of a little quick crash course. Actually, let me just do this. Let me do another one. All right. Let's try 4x minus 3y is equal to, let's try equal to 9. So in order for me to graph this, I want to find the slope and the y-intercept. So as we did before, let's get y by itself. And we do that by first moving 4x to the other side as a negative 4x. So negative 4x plus 9. And then we're going to finish by dividing everything by negative 3. So we have y is equal to, now you've got negative 4 divided by negative 3, so that's a positive 4/3. Don't forget the x, and make sure you put it in the correct spot. Positive 9 divided by negative 3 is negative 3. So in this form, we can pick off the slope because that's going to be the coefficient of x. So that's 4/3. And then my y-intercept is going to be the ordered pair 0, negative 3. Again, the y-intercept is a point, and you must give the point as an ordered pair. So now that we have our information, we're going to use this to graph our line. So 0, negative 3 is going to be down here. So 0, negative 3. And then we use our slope. Remember, your slope is that ratio of rise to run. So because this is a positive slope, as I go from left to right, I'm going up. So it should be slanted up whenever we graph this. If it doesn't, then we've done something wrong. All right, so I'm going to go up 4, so up 4 and then over 3. Go up 4 again, go over 3, and we keep on doing that. If you have done this correctly, you should be able to take some ruler or whatever and be able to line up all the dots correctly. They should all be on the same line. And now let's flip this around and get some points on the left side. So instead of going up and to the right, let's go down and to the left. So I'm going to go down 4 to the left 3. If I try doing this again, I'm going to be off the grid. So let's just leave it as it is right here. And let's connect the dots. Please make sure that you remember to put arrows at the ends of your graph. The arrows are there to signify that this graph is going to continue on off the paper in that particular direction. Now, let me pick, let's say this point that's up here. So we have the ordered pair 9, 9. That's this guy right here. Again, I should be able to plug that into the original equation and have something that is true, right? So if I do 4 times x, which is 9, minus 3 times 9, let's see what we get. It's 36, minus 27 equals 9, so everything checks out. Yeah, so that is graphing. Not too bad. Now sometimes you'll run across problems that look like this. If I say x is equal to 4, if that's all I say, x equals 4 and there's no y here whatsoever, this is still a line. And what it's representing for us is it is a line that no matter what you do, x is 4. The y value can be whatever you want it to be. You could say y is 0. Doesn't matter, x is 4. You could say y is negative 3. Doesn't matter, x is 4. You could say y is 5. And again, it doesn't matter because this equation says x is 4. There's no y here in the equation where they work together and they kind of work off of each other like what we had on the previous page. So when I put all this stuff together, I have 4, 0, 4, negative 3, and 4, 5. And I hope that you can see the graph that we have here is just going to be a vertical line. Now let's talk about the slope for this though. So we've talked about how slope is the ratio of rise to run. So if I do rise over run here, the rise from the first point to the second point, you're going up 5 units, but your run is 0 because you didn't go left or right at all. And 5 divided by 0 is undefined. So that means that anytime you're dealing with a vertical line, the slope is undefined. If I had done x equals negative 5. Now, whoops, put that in a bad spot. So if I did x equals negative 5, that means you'd come over here to negative 5, and you would draw a vertical line, arrows on the ends, and this would be the graph for x equals negative 5. And the reason it's a vertical line is that x can only be negative 5 for that example. If you were to tilt this to the left or to the right at all, then x would no longer be fixed at negative 5. It would be something else. Y can be whatever, but in this equation it says x equals negative 5, and that's it. Let's do another one of these. All right, so that was when we had just x. But if I have, let's say, y equals 6, if I make a t-table of values with this, notice how this says y is 6. Y has to be 6. So if x were 0, y is 6. If x is 2, y is 6. If x is 5, y is still 6. This says y equals 6, and that's all it can ever be. There's no x that's there that can change it. Y is 6. And again, if you plot these points, 0, 6, 2, 6, or 5, 6, these guys are going to all line up on the same line. So we connect the dots, and there we have it. This is a horizontal line, right? Now, we see that as we go from left to right, this guy's not going up, he's not going down. And let's try to calculate the slope here. So as I go from point to point, what happens? So if I calculate the rise to run, from the ordered pair 2, 6 to 5, 6, there is no rise. You're still at the same y value. But your run, you've gone to the right 3 units. And when you have 0 divided by 3, you end up with 0. Now, up above, just remind you real quick, when I was dividing by 0 in terms of calculating the slope, I came up with something that's undefined. You cannot divide by 0. It gives you an undefined expression. But you can have 0 in the numerator. So 0 divided by any non-zero answer or non-zero number is going to be 0. And so here's what we know, or we can see here. So when you have just x equal a number, this is going to be a vertical line, and you're going to have an undefined slope. Because it's going to be going up and down, and sure, there's rise, but there's no run. So you're dividing by 0, which makes you undefined. But if you have y equal to a number, like y equals b, you have a horizontal line, and you have a slope of 0. So it's important to remember these guys, because later on we're going to be talking about horizontal and vertical lines in terms of things called asymptotes. And that's going to be, I think, next week? I can't remember. I'll have to look. Yeah. All right, so let's move on to the bigger topic here for the rest of our time, and that's writing equations of lines. And so what we're going to do here is I'm going to give you certain pieces of information about a line, and we're going to find what the equation would be for that line. For example, if I say the slope of a line is 2, and the y-intercept is the ordered pair 0, negative 19. How could we write an equation that has that slope and that y-intercept? Well, for me, I prefer to just go ahead and start with the slope-intercept form. Y equals mx plus b. And you'll see that right now, we have the slope, and we also have that b value because we were given the y-intercept of 0, negative 19. And since that is the case, let's make those substitutions. So y is equal to 2x and then minus 19. That is the equation of our line with that slope and that y-intercept. Now, this is the slope-intercept form. But sometimes we want to have to write this, or we may be asked to write this in the standard form. So standard form means x's and y's are on the same side, and the constant is on the other side. So let's try to get it to be that way. So the easiest way to do that is to first move the variables all to the same side. Now when I move the 2x over, that becomes a negative 2x. And then we got plus y equals negative 19. All right, so this is mostly standard form. Sometimes there are added restrictions to what they want for standard form. So they typically don't want to see fractions, and they don't usually have a leading negative coefficient. So the way that we can fix that is that we can multiply everything here times a negative 1, which now gives us a positive 2x minus y equals positive 19. So this will be our answer in standard form. And that's pretty much all there is to that. So if you've got the slope and the y-intercept, you're pretty much done. But it's not always going to be that easy. So what if we have the slope is positive 5, but then I say this, I say that we're passing through the point, let's say 7, 2. Let's see if we can write an equation for a line that has that slope and passes through that particular point. All right. So if I go back to my slope-intercept form, y equals mx plus b. Right away, I've got my slope. Perfect. But what I don't have is the value for b. Don't try to go to the 7, 2 and say, oh, isn't b 2? No. B is supposed to come from the y-intercept, but we don't have that. What we do have is a very specific solution for our equation x and y. We can use the x and y, plug in the x, plug in the y, and all that we would have left to find is the b value. So you know what? Let's try that. So my y is 2, slope is 5, x is 7, and then I have plus b. That's the guy I'm trying to find. All right, so let's work this out. 2 equals 35 plus b. And then we want to solve for b by moving the 35 to the other side. So I'm going to go ahead and write minus 35 here because it's a little bit easier for me to, if I see it. So b equals 2 minus 35 is negative 33. This is not my answer, but I'm going to use that with my slope, which is 5, and I'm going to write my equation from that. So that means y equals positive 5x and minus 33. That is going to be my final answer. This is an equation that has a slope of 5, and it has that 7, 2 as a solution. Now, if you don't believe me, take a moment and check this, right? If I were to plug in 7, do I get 2? So let's see, if I do 5 times 7 minus 33, what happens? Let's see, 5 times 7 is 35, minus 33, and yeah, this does equal 2, so I know that my equation is correct. So, nice and easy, right? Well, sometimes things are not always so nice and easy, especially when they do something like this. If they say that the slope is negative 2/3 and a point that we pass through is 12, negative 16. Now, it is going to look very similar to what we did in the last problem. If we start off with y equals mx plus b, I hope that we can identify that right now we definitely do not know the b value. But we are given the slope, and if I use this as that specific solution for x and y, I plug in the x, I plug in the y, And when I solve this, that's going to tell me what my b is. All right, so let's plug in. At y is negative 16. My slope is negative 2/3 times x, which is 12, and then plus b. Now, don't be afraid of multiplying fractions. Remember, 12 is 12 over 1. We can reduce this because 3 goes into 12 4 times. And this gives us the equation negative 16 equals negative 8 plus b. Solve for b by adding 8 to both sides. And we end up with b equals negative 8. And just like we had previously, we're going to take my b value and my slope, and we're going to combine these guys. So y equals my slope, negative 2/3 x, minus 8. This is my slope-intercept form. Now, suppose we want to put this in standard form. So go ahead and box this so this guy is okay. But now I want to try to go into my standard form. So to do that, I need to first move my variable term to the left. So I'm going to put that in front. So that's 2/3 x plus y equals negative 8. And like I said before, in standard form, we typically don't leave fractions running around. So we're going to multiply everything times that common denominator. It's really the only denominator here, which is 3. So multiply everything here times 3. And when we do that, let's see, those guys reduce. We have 2x plus 3y equals negative 24. So this would be our answer in standard form. So depending on, like what homework system you're working with or what teacher you have, you need to be able to quickly convert from slope-intercept to standard form or vice versa. All right. Now let's make things a little bit more interesting. Suppose I give you an example and I say that the line is passing through the ordered pair 31, 76, and 35, 88. So with this, I didn't give you the slope. In all the other examples, I gave you the slope. So what do we do here? Well, we can find the slope. So there's a formula that I gave on another page that said the formula for the slope is the change in y over the change in x. All right, so let's do that. Make sure you label these ordered pairs correctly. Now, it doesn't really matter which one is the first and which one is the second. What matters is that if you say this is x1, then the corresponding y value is y1. And then you have x2, y2. When you plug into this formula, you have to be very careful. Anytime you're doing substitution, you want to make sure that you use parentheses. So I'm going to have y2 minus y1 in the numerator. The parentheses are there, and that minus sign is because there's subtraction in the formula. And the denominator is going to be x2 minus x1. And now we just plug in our values. So y2 is 88, y1 is 76. x2, I'm pulling from there, is 35, and x1 is 31. Now, you might say, why did I need parentheses here? It's good habit, it's good practice. Plus, if the ordered pairs had contained negatives, doing it with parentheses keeps you from making a mistake with a negative. Okay, so always put the parentheses and then plug in those coordinates as you see them. All right, so let's keep working this out. We've got 88 minus 76 is, this is going to be 12. 35 minus 31 is 4. So we end up with 3. This is my slope. Not my answer, but it's going to help me get to my answer. And now we're going to do just what we've done on the previous page. Let's go back to y equals mx plus b. I need to find my b value. Okay, I don't have that, but now I have my slope. And I can choose either of these original points as my x and y, so I can plug that in and find my b value. Now, I frankly don't care which one you use. You probably want to use the one that has the smaller numbers. So I'm going to choose this guy right here. So when I do that, my y is 76, my slope is 3, my x is 31, and I'm going to solve this to find b. All right, so let's just do the math here. 76, 3 times 31 is 93. And then finish solving for b by subtracting both sides by 93. So 76 minus 93 is, make sure I don't make a mistake here, is negative 17. Now, if you had used the other ordered pair, what was that? 35 and 88. You should have had the same answer. So by taking my value for the slope and my b value, I get the equation that y equals 3x minus 17. But wait, there's more that I want to show you here. So this is me using the slope-intercept form because, frankly, I think it's the easiest thing to do. Some students prefer, bless you, to use the point slope formula. Y minus y1 equals m times x minus x1. Again, I'm not the biggest fan of this. But what we're going to do is we're going to plug in what we know. We've got our slope, and we can choose one of those ordered pairs from above to plug in. So let's do that. So I'm going to have y minus, you know what? I'm actually going to pick the second ordered pair here so that you can see that we end up with the same result. So that y value and the other one is 88 equals slope is 3, and then we have x minus 35. And again, if I've done things correctly, I should end up with the same result. So let's say y minus 88 equals, when you distribute, you get 3x minus 105. Doesn't really look the same, but wait. If I put this in slope-intercept form, I can accomplish that just simply by moving the 88 to the other side. So y equals 3x, and if you look at negative 105 plus 88, you get 17. So it's the same answer. We used a different method. We used the other ordered pair, and we still got the same result. So I think that's pretty nifty. Now, let me talk to you about some pros and cons here. The pro to using the form that we have here on the right, that point slope formula, is that it doesn't require you to find a number and then plug that back in. It is a complete equation once you distribute and you move terms over. The con is that if you are plugging in negative coordinates, it can definitely be confusing because then you have the minus and you have the negatives, and if you're not careful with your signs, it's easy to make a mistake. When I use the slope-intercept form, I get a very simple problem. I don't have any subtraction as part of my formula there. It's just I got to multiply the slope times the x, move it over, and I get my b value, and then I take that, combine with my slope, I've got my equation. So I like the simplicity of the slope-intercept form by approaching it that way. But again, that's just me. All right. Well, I guess we should talk about parallel and perpendicular lines, right? So just as a quick reminder, remember that parallel lines have the same slope, but they have different points. Same slope, different points. And typically what we see is we have different y-intercepts. That's a really easy thing to check. For perpendicular lines, so for perpendicular lines, students may say, oh, these are lines that cross. True, but there's more to it than that. They intersect to form right angles. So let's make a little note here. So these are lines that intersect. Oops. Lines that intersect to form right angles. And let me go back to the parallel lines thing real quick. Some students say, oh, these are lines that run right next to each other without touching. There's nothing that says they have to be next to each other, right? They just have to be on the same plane and never touch. So the same slope in different points. For perpendicular lines, the slopes are negative reciprocals of each other. The slopes are negative reciprocals of each other. So parallel lines and perpendicular lines in a nutshell, when we look at them in terms of their slopes. So let's keep writing equations of lines using this information. So if I say I want to be parallel to the equation y equals negative 7x plus 2/3, and I want to pass through the ordered pair, let's say -3, let's say -3, 4. Well, we know that with all these problems so far, we have to have a slope. Sometimes it is given to us, but then sometimes we have to go and find the slope like we did in the last couple examples. But here, I want you to see this. From this equation that they gave us, the slope here is -7. And then the slope that is parallel, so we usually use parallels like those two little vertical lines next to each other, it's going to be the same value. Perpendicular lines have the same, my goodness, parallel lines have the same slope. And so now I'm going to go into my slope-intercept form, y equals mx plus b. I've got my slope, and as we've been seeing so far, I've got my x and I've got my y coming from this point that we're going through. And so all I would need to find is my b. So y is 4, m is -7 times x, which is -3 plus b. All right, so 4 equals positive 21 plus b. Solve for b by subtracting 21. And we have that b equals -17. So, take your slope, take your b value, and put it together. So y equals -7x minus 17. And when you compare these two equations, you'll see that their slopes are exactly the same. They're both -7. And they have different points. And we can test that very quickly by looking at the y-intercepts. The y-intercept for the original equation is going to be 0, 2/3. For this new equation, it's going to be 0, comma, negative 17. So by starting at different points on the y-axis and having the same slope means they're never going to touch. So they're going to be parallel. Let's do an example with perpendicular lines. So if I want to be perpendicular to y equals 2/3 x minus 5, and a point that I go through is negative 16. All right, let's see what we can do here. Too far. I see that. I see it. All right. From this equation, this is the line that we're supposed to be perpendicular to. My slope is 2/3, which means my perpendicular slope, so we use that little upside down T-looking shape. We said that perpendicular slopes are going to be negative reciprocals of each other. That means I've got to take my fraction, turn it upside down, and change the sign. So it was a positive 2/3. The perpendicular slope is a negative. Flip the fraction, 3/2. And now we've got our slope. We've got a point that we're going through. And so let's use that in our slope-intercept form, just like we've been doing. I've got my slope. I'm going to use this particular ordered pair for my x and my y. Plugging it in, all I'll have left to find is my b. All right, so let's do that. My y value is negative 16. My slope is negative 3/2 times x, which is 10, plus b. All right, so 2 goes into 10 5 times, so easy simplifying there. Negative 16 equals, we got negative 3 times 5 is negative 15. And then we finish getting b by itself by adding 15 to both sides. So we would just have b equals, and combining the stuff on the left, negative 16 plus 15 is negative 1. So now we take our slope and our y-intercept, and we put these guys together, so we have y equals negative 3/2 x minus 1. So we take the equation that was given, we identify its slope, and then we find the negative reciprocal so that we can find the perpendicular slope, combining that with the ordered pair, and we have our equation. Now, there are a few more things I would like to say on this, but we've reached the end of today. Now, you definitely want to make sure that you come back on Monday. Now, I'm not sure what time, so look for announcements on my YouTube channel. I'll try to post something about that so you have an idea about when I'll be streaming next. But yeah, so next week we're going to be talking about graphing. We're talking about functions and relations, domain and range, and graphing non-linear functions. And function operations and composition. So basically it's going to be a lot of arithmetic. It sounds fancy if I say function notation and function operations. It's really nothing more than, can you plug numbers into a formula and get the answer? If you can do that, you're going to be good to go. Thank you everybody for watching. And again, please make sure that you like, subscribe, share, and all that stuff. Really do appreciate that. And until next time, have yourselves a fantastic weekend. Yeah, weekend. That's right. You guys have a good weekend. Ta-ta.